So welcome to another episode of Spark Talk. This is a special episode of After Hours Shop Talk. And I've got Matt Yarmuch with me here.
Pleasure to be here.
My special guest.
Thank you.
Comes around now and then when we do some special projects like PQRs, WPSs, and other qualification related items.
Great to be here. Great to be back. How do you know it's After Hours Shop Talk? Well, because we're gonna have a beer along the way too. So it's always good. That's usually how the end of the day goes. But during the middle of the day, we're busy at work, trying new technology and trying new things out. So it's interesting when you start talking to companies about welding or automation. What's the first thing that comes to mind? Productivity, right? Being more productive, weld it faster, get that, like we have a little weld shown there, get that done faster, quicker, get rid of the bottlenecks. And it's interesting. And you've seen this over the years too, is so many companies go in with it that welding's our bottleneck. We got to be faster. We got to be more productive. And they solve a welding problem and then they create a whole bunch of other issues. Welding and automation is not this magic black box you put in the corner and solve the crowd is. You have to look at that whole holistic approach to how you're bringing this technology in. How are you handling your materials, your fit up, your preparation to feed the automation system? And then how are you taking it away to the next phase of processing it or inspecting or what have you? And those become such important considerations, especially fit up. Like, what are your thoughts about fit up?
Before we get too far, what qualifies you to talk about all this and help me?
Wow.
What's your background?
So my background, well, like you mentioned, we've been working together. So I've been working with Novarc for about a decade now. And my work with the organization has been really focused around bringing these technologies forward. So my background is actually in engineering. Actually, we go way back to a young guy in high school. I worked in welding shops and fabrications, worked on pipelines in northern Alberta and other areas. So I worked a lot of my hands on the tools. I wasn't the best welder in the world or a fitter, helper, but that's where I started. And then I went to university, did an engineering degree in materials engineering. So materials and metallurgy, learning about stainless steels and carbon steels and all these fine metallurgy, and had this opportunity. It was sponsored by a company called Syncrude Canada, large oil and gas company, and they sponsored me to help do a program in welding engineering. So now I'm a welding engineer retained by many companies, such as Novarc, to help them with their qualifications, their procedures, their technology adoption, and making it make sense and making it work for them and what they do.
So you know a thing or two about welding?
I like to think so. I like to think that there's an element of an appreciation for the hands-on skilled trades aspect. That individual that can make the art do what it needs to do, that has the muscle memory, the skills, the aptitude to make it work, to physically fuse the material together. And then the more formal academic education has been great to understand, what's going on in the art? What's going on in the metallurgy, the properties that can get out of it. So if you can understand and appreciate both aspects, you could do some awesome things, especially when it comes to automation or technology. You can really maximize what you can get out of the system.
Cool, very cool.
Yeah.
Well, pleasure to have you here with us again.
Thank you.
I'm Ringo Gonzalez. For those who are seeing us, I'm a director of welding innovation here at Novarc, and I try and help the company push forward new development procedures, new weld technology with the help of Matt. Whenever I have highly technical research to do, I always consult Matt, see what he knows. He knows a thing or two, as you just heard, his background. So that's my job, and I really like this field of work with mixing pretty artistic, art form of joining things together with automation technology, robotics.
Yep.
I like that.
It's kind of a cool mix, right? You don't lose the essence of what welding is. The hot metal fusing together, the balance of energy and making that puddle fuse in that way you want it. And then with automation, you can start doing, let's be more productive. Let's try new materials. Let's, we'll probably talk about artificial intelligence. Let's bring in machine learning and other aspects that could even, things that felt like science fiction a few years ago are reality now. And you do some amazing work here, Ringo, with you and the team on the research and development side. That when I'm out talking with folks and just saying this is where we're at, not where we might be, this is where we're at. It blows some people away that how amazing some of this technology is now, and just that it's readily accessible. It's digestible for a company to take it and run with it day to day. And it's not intimidating, it's actually empowering for the organization.
Cool. Very cool. So we want to talk a little bit about shop flow.
Yes.
Right?
Shop flow.
What can you tell us?
Well, I kind of mentioned it off the hop. You know, when you look at automation or welding technologies, it's not a magic solution. It's not this magic, like I mentioned earlier, this magic black box you put in the corner and it just resolves it. You have to understand where your bottlenecks are, where the issues are, what's slowing you down, where that injection of productivity in production, what that means. So you have to look at it more holistically. I'd tell that to business owners and shop superintendents, foremen, and welders, and they go, what do you mean by holistically? It's like, well, think about the steel coming in one side of the shop, being cut, prepped, this, that, fit up, welded, moved, arranged, inspected, and then on a truck and shipped on the other side. Because if you all of a sudden, if welding is your bottleneck and you're much more productive and you don't look at some of those other elements, you might be kind of making some more challenges for yourself. So the more holistic and looking at your overall shop flow and efficiency, you know, people talk about Lean, Six Sigma, Kaizen, like all of those sorts of philosophies. That's really what we're talking about is automation, and welding automation becomes one of those high impact tools and systems you could start adding to a shop that has good workflow.
To get good workflow, one of the most important things one would say would be fit up fabrication, right?
Yeah.
So I've got a little coupon that I'm going to bring.
Sure. Control it. All right, you grab that. It's always good to, when you're looking at fit up, to actually have something tangible in your hand to play around with. Oh yes, we've used that for some of the training workshops that we've done. Yeah.
So here we have some examples of tacks, root opening, what a root looks like on the inside.
Making sure it's great, the touchy feely, because you can have drawings and specifications and the engineering of it, but you need the tangible details as well too, right?
So how important is this in fabrication and automation?
Critical. So the analogy I love to use for fit up and preparation is it's like painting a wall. So the actual process of applying the paint isn't too difficult. Let's say it's just a regular, straightforward wall.
Yeah.
But you know what's the hardest part about painting a wall? Cleaning it, patching the holes, sanding it down, doing all the prep work, the fit up.
The taping, the color.
Taping, and doing all of those things, right? So the same analogy, so taking that analogy here to piping fit up, the fit up, whether it's automation system or manually weld, it doesn't matter. You garbage in, garbage out. If the more you can put into your fit up processes, the better results and consistency you will get. 100%.
So, yep, along those same, points there. Guys want us to weld 532 gaps and things like that. What should be a response with automation for that kind of environment?
In automation, you're all about trying to optimize and get into optimized ranges, and so there is a bit of a change in perspective that what you would typically do for a manual, semi-automatic, traditional workflow might not fit in automation. It doesn't make sense anymore, or you're overwhelming. You're putting more weld metal in than you need to. You're taking more time than you need to. So I know you got your handy tool for actually measuring fit up to demonstrate how you get to those optimized fit up areas. Because you do that, you're reducing the amount of joint, the amount of weld metal you have to deposit, reducing your welding times, and you start multiplying that by multiple joints. You're saving productivity, and as well, overwelding doesn't help the weld quality. There's no benefit to it either. So from an engineering perspective, there's a value add of more efficient and optimized you are, the better the joint is.
We could do a whole episode on efficiency and maximizing the efficiency of a shop flow.
Mm-hmm.
Starting with the fit up, right?
And it's almost like go for a walk in the day of a piece of steel, where you literally walk with that piece of steel, like I said, from one shop,
like a traveler, following the piece of steel from beginning to end, right?
Yeah. So maybe you have a burn table or the bandsaw or however they're prepping it, cutting and doing the prep work. There's all these elements along the way that become critically
very important.
So you should show up that tool. So you designed that, hey?
I did.
So tell us about your little.
So this is called the RGM.
Yep.
And it's got a lot of functions. I'll just talk about a few right now.
Sure.
You've got the ability to check your bevel angle when you cut a pipe.
Yep.
You can check the edge, make sure that it is 35 or whatever you have here,
yep.
35 and 30. You also have the ability to check post-cut. So when the fit up is done already, you can still check the geometry.
Right.
It's like, oh, that's 70 degrees, which means the bevels were 35 and 35. Yep. Or this is actually 60. You got 60, 70 degrees. And then we also have a offset to check your weld reinforcement.
Okay.
1/8.
1/8 reinforcement.
Yeah, 1/8 reinforcement.
Awesome. And then you can see for different gaps that you might have, weld gaps. So
very important.
Yeah.
To measure the gaps, you got 1/16, 332, 1/8.
Yeah.
So if this thing swims in there, it's probably over 1/8, right? We like to live in the world of 332 to 1/8.
Yeah.
No bigger than that.
Right.
1/16 we can do, but we recommend 332 to get good penetration, right?
Absolutely.
And I'm not done with the functions.
Okay.
One most important function. Bottle opener.
That's the best part, isn't it?
One of the best parts, right?
Yeah.
You can also wear it as a necklace, keychain.
Yeah. Careful if you're going through customs at the airport, right?
Well, you don't want to explain to customs what it truly is.
Yes.
Because you're going to confuse them.
Mm-hmm.
You want to tell them this is just a keychain.
Yes.
It's a keychain, right?
Yeah.
As soon as you say the word pipe at the airport, people don't follow you further. Like security, this guy over here.
Mr. Gonzalez, come with us.
Walk this way, sir.
Well, it's pretty cool though, but it speaks to the importance. Like, so you mentioned walking, being the traveler, having that day walking with the steel, and little things like that.
Before you get traveling, cheers.
Oh yeah, cheers. Cheers. Thank you. Thanks again. The importance of that is having, I love to call them the go, no-go gauges. And so if you're looking at a weld shop flow, every step along the way, you should be having go, no-go gauges. Not what people think they want, what they did last time or what they historically do. You have to have a box that they can work in. You don't want to make the box too narrow because it's too confining.
A range.
Yeah, a range.
Well, no-go.
A range. And the range might be new and different. And change is tough. Change is tough for anyone, whether you're a welder fitter, you're a technologist, you're an engineer. Change is tough for anyone. And so when you're bringing automation in and you're attracting people into the workforce and trying to entice them into doing this work, technology is great because it gives a way to attract people in. But when you're working with people that have experience or used to doing it a certain way and that change is tougher for them, you have to have some empathy. There's an expression too, the tail does not wag the dog. There is a point where you have to say, no, this is how we do things. This is how we produce. And this is what our organization does. So you got to find that balance. Like you say, that operating window of work within here. That's cool. Find your spot, but you start deviating out of it and we have to kind of bring it back in.
Yeah. One of the hardest things that I encounter when we teach people about how to use automation and efficiency and the optimum fit up is teaching guys how to prep their tacks and teaching them how to tack, right?
Right.
Because it feels a little bit like you're walking in and telling someone that you're going to show them how to tie their shoes a better way. Or they've been doing that wrong their entire life. That's how it feels.
Hey, for sure. And part of it is historically, if you talk to a lot of companies, organizations, tack welds were just go and do it. And so it wasn't.
Well, because most of the time they remove them, right?
A lot of time they're temporary, right?
Yeah.
Versus here, we're integrating them into the weld.
Right.
It's all approved. It's acceptable. It meets code. It's part of an approved procedure. So there's not a compliance issue, but it's new and different. Like we talked about that, new and different. And so if it's temporary, it's like just slam it together and you're going to grind it out and carrots. But now it's like, the way you've been tying your shoes actually, to use that, I like that analogy is it's almost, you're tying your shoes wrong because, and it's not that you're an idiot. It's not that you don't know how to do it. It's more of, to make the technology work, we have to approach it differently. And sometimes those conversations go well and some people buy into it and it's okay. But as you know, and as we've experienced on the shop floor, sometimes that can be a more challenging conversation. Is that a good way to put it?
Absolutely. And the thing is that we want to tell people that you're not doing something wrong. I'm just showing you a different way of doing it that automation likes, or it's friendly with automation, it's more efficient, and it's just going to maximize your workflow.
Yeah, it's optimized. It's getting that mentality of what you've done in the past isn't wrong, but what we're doing now is different.
Optimize is the right word, yeah.
Optimize in a new way, a new operating window, new expectations. So that old way of doing the tack welds was fine. And what you weren't doing anything wrong, but it doesn't fit the operations going forward.
Right.
So again, when you're attracting new people into the workforce and you can train, coach, train, and mentor them,
right,
it's a little bit easier. Or, I mean, not easier, but you can start them at the ground level. But again, when you're going into, where you have some experienced folks, it can be a bit more challenging. So,
yeah, true, very true. Attracting welders to the workforce. How do we deal with that?
Well,
we have a challenge nowadays. Like we have shortage of welders,
shortage of so many trades. Right? It's
right.
really tough across Canada. So we're in BC today. Same problem in Alberta, where I was this morning. Across Canada, there's challenges. The United States, Europe, Australia.
And where does it come from? What's the big challenge? Truly, what do you think?
No, that's the $1 million question. I think it's a lot of different factors. The demographics have changed. So years ago, you grew up, if you would take welding maybe in high school. So there are still high school programs. There's some great high school programs, but not all the time. Or your mom or dad might have done it, so you would do it. But there was a shift for years and years to say, oh, don't do the trades. They're dirty. They're old school. They're not a good. Go to college. Go to university. Go and do something else. And there was a long period where that was a message, right or wrong. People just felt a certain way. And now we have to, and we have been, I think, as an industry, reframing the conversation of saying, consider the trades. We'll use welding as an example. Do that, and then maybe do that for a number of years. Then maybe consider other educations. It's not. Don't give up on other education paths. And just be a welder. It's like, no, be a welder. Do that and enjoy it, and then you can always consider other paths. So I think we have to reframe the conversation. We also have to shake the old image of welding that it's dark, dirty, old school, old technology, nothing new. And we got some shiny new equipment. This is the pendant for running this system, right? I always like to say this is kind of like the old school Game Boy or the Nintendo Switch now, or the PlayStation or Xbox, controller, whatever, right? Yeah. You can run it through a screen. It's things like this.
So that's a new way of welding.
It is. As an operator, you're interfacing with the arc and the weld differently, as opposed to using your muscle memory to articulate it by hand. You're using it in a system. So to me, this becomes a way to attract. There's two elements. I think it's attraction and retention. So attracting people into it, the trade, and retaining them so that they don't do it for a few months or maybe a couple of years. Like, I don't like this. I'm moving on, right? So, you use this as for day in, day out. So you speak to how that has changed for you in your personal life of being a welder yourself and now being an operator through the system.
Yeah. Well, my favorite part is that you can mount it like a fanny pack.
Yes, of course. Makes something look pretty, right?
Totally.
Yeah.
Very comfortable. No, I think it's really cool that I can weld 15 feet away from when the puddle is. Right. I can be controlling the weld from a distance. I'm not exposed to the fumes. I'm not exposed to the radiant heat, the arc light. I'm in a safe environment, but I'm also controlling so many variables that I can never do by hand. So by hand, you could be shouting at a guy 5 up, 5 down, right?
Yes.
But that's just one variable.
Right.
Here I can control the amperage, voltage, oscillation,
Wire feed speed.
travel speed, wire feed speed, so much. I got
So many
access.
things at your fingertips.
Absolutely.
Yeah.
So you do feel immediately like a smarter welder just by using this controller.
It's amazing how that interface, not only is it appealing, it's something interesting and cool to attract people in, but if they get used to it, you realize, they'll still manually weld. That'll be part of their training, but if they're using a system like this, I think they'll probably came to that same point that you're at, where this is, I could do more this way than I could ever dream of manually, right?
You also understand the welding process a lot more when you're using this controller because you can see the changes you make to the individual waveform itself, just by changing some of the parameters.
Yeah.
That's pretty cool.
That is really cool.
As an instructional, also, tool.
What do you think? Do you think that's one way to attract people in is technology? Do you think that's part of the
Well,
solution?
I think so. I think colleges, trade schools need to adopt this type of technology more instead of just saying, "Oh yeah, that's great. That's good. Glad you're doing it." They should actually buy into it and invest so they can educate and attract the younger generation to the new automation technologies that we offer.
And we have to really work with because training institutes, right? They'll do what the curriculum says, what the apprenticeship programs. So that's at a provincial level. So I think part of it is advocacy to the government through industry associations.
Advocacy from the trades.
Yes, and I know you're involved. I've been involved in industry associations and co-committees and stuff. And I think those are great venues. Also, so you talked about why are we. Some of the challenges that we have to attract people in. And part of it is people have to just kind of stand up for it and say, this is a good career path, something to think about and something to be proud of. Right?
Absolutely. No, it's a big challenge. It's a big challenge to get institutions to buy into this technology because they are really just following the curriculum that's been mandated by this governing body group that is very hard to lobby with and convince.
So what do you think is the toughest factors of attracting the people into the trades, or why that has changed so much over the last, let's say, 25 years or so?
I think it's much of the several reasons you just mentioned. If there's anything I can add to that, I think the negative stigma of welders and trades is still there. So parents, if your dad is an accountant or your mom is a doctor, they don't really encourage you to go into the trades. That's considered dirty work for people who are not so smart.
Right.
That's sort of the mentality they have.
That can be there, yeah.
Archaic. Yeah. So unfortunately, that's not the reality. The more I work in this field, the more educated people I see, highly intelligent people with masters in other areas coming into welding.
I mean,
because for one, they never wanted to be working behind a computer all day.
Right.
They were in the wrong career path from the beginning for whatever reason. Their parents just forced them to. And working with welding, there's no end to the science. You can get as much as you want into physics, chemistry, or art. But I think removing that stigma by just promoting welding and trades in general on media and the benefits it has. So I think it just makes people so much more capable of doing everyday things in life, from fixing to building, it just makes you more capable, and it's more rewarding to be able to build with your hands.
More well-rounded, right?
More well-rounded.
And it's not to say there's anything wrong with a formal education or an academic training, and there's so if that's the right fit for someone, great. And it's more of acknowledging the importance that the trades have. That a lot of ways Canada was built on the trades, the hard work of farmers and tradespeople over the last few hundred years. Canada being a relatively young country, it was on the backs of a lot of people working hard day in and day out. And so we want to adopt and embrace modern technologies, but we can't forget where we came from too.
Absolutely. I think it's just a matter of having a historical perspective on what builds, the world. You don't build railways, with just doctors.
Right.
You don't build cities You know, you don't build airplanes.
And let's take it a next step further. You don't build high-speed levitation
With
trains, that go 300 kilometers an hour without tradespeople using amazing modern technologies either, right?
Yeah.
So, it's that, railways, that's old school. No, it's
Yeah.
it's actually
It's not old
amazing.
school.
It's not old school, yeah.
Yeah.
I think what we're actually getting towards is just the culture.
I
The
think
culture, maybe it's
huge.
family culture and shop culture, right? Like
Yeah.
that's a huge part of the prevalence of the trades or automation.
Yeah, and you also
adoption.
mentioned demographics, right?
Mhm.
All the people moving into, North America from various parts of the world
Right.
don't necessarily view welding as a viable option career path
Right.
or as a, way of making a good living. Because in that part of the world, wherever the people come from, it's not considered a professional, occupation, let's just say.
Right.
Right? So that's
Just something
a big factor.
It's something they just do.
Exactly.
Yeah,
It's just
yeah.
something, your neighbor did, to get by.
Right.
Yeah. So yeah, it's
Have
what
to
I think.
change that. So
Yeah.
it's interesting. So we take that. We have to attract people in. Let's assume we can attract some new people in. But let's say you want to take this new technology, like new automation, and go to a different shop. And you've been to many, many shops over the years. You've worked in many shops. You've had that pleasure. I've had that pleasure as well. It's an interesting spectrum of shop cultures you're going to see too, right? And it's interesting. So we talked about all these benefits of automation, wire processes, being more productive. How do you get buy-in though? What are your thoughts? What are some things to do with folks on the shop floor to get some buy-in where this eventually gets dropped down on the shop floor for them? They're going to buy in and they're going to own it and make it work.
Well, I think that's really important, take. You need to make sure that there is some communication between management and the shop floor. There has to be communication. If there isn't communication between management and shop floor, you can't have the shop floor, welders adapt technology very well because they just see it as something that may take their job
Right.
because it was bought by the executive part of the company.
And they just try to save a buck.
And they're just trying to save a buck.
Yeah, which is not fair in either direction. Right?
No. So that's really important. I think when we market our automation, in welding, you need to also have a focus on the welders themselves,
Right.
not just the top line, not just the numbers, right? You need to emphasize on what the benefits are to the welder. For example, the way I see this technology that we have is a special robotic arm that belongs to the welder to allow them to make better and faster use of their skill.
Yeah, I would agree. I think that's a well said that. And one thing I've always loved about Novarc's approach is it always had the welder in mind, the ergonomics of the pendant, the setup, the quick setup. There's always the welder perspective. Because in a way, if you make the system work for the welder and what's best for the welder, so that they're more comfortable, they're safer. They're not sucking on fumes all day. Like you mentioned earlier, fumes, they're radiant energy, just the physical toll on your body, right? All of those aspects, the ergonomics are improved. So if you take care of the welder and they're more comfortable and more productive, and there's no fear, it's not punitive, they don't fear that they're going to lose their job. The economic aspect of it, like we talked about at the beginning, the productivity to the return on investment to the ownership, which is still part of the equation, right? Mm-hmm. It's a business.
Yep.
That will come.
Yep.
That will come naturally. And that's the beauty of it. It's more of, if you go in the mindset of, we need to save money, so make this work, as opposed to, hey, I'm going to work with you on the shop floor to have the buy-in. And knowing that if we make it work on the shop floor, then the return on investment just comes along. Right? And it's an interesting conversation. Some companies get it. And I know some of our customers, Novarc's customers, they get it, and it's a smooth transition, and they get that culture buys in. other ones, and I might be going to visiting a couple of those companies here in the next few weeks, where it's roadblock after roadblock after roadblock. So it's kind of a spectrum of culture in a shop, right?
Yeah.
Some cultures are going to be very accepting of it. Some are going to hit roadblocks. So what have been some of the things you found are successful when you're talking to those welders on the shop floor to put their mind at ease that this is not stealing their job, this is not taken away, this is not because they've been doing anything wrong in the past, this is just we're developing a new approach. Like what are some of the things that you've done to make that work?
Well, I try and focus on the fact that we don't take jobs, for one. I let them know this is much like a sub-arc, technology. What does sub-arc do? It deposits a lot of metal real fast.
Yeah.
Do you want to stand there and do that yourself?
Mm-hmm. Holding it like this.
Depositing a 1/4-inch diameter wire?
Yeah.
I don't think so.
Yeah.
Now, even if you could, physically, as a human, if you could, you wouldn't want to do that. For any money in the world, you will go numb. You will destroy your body, right? So that's why we have sub-arc. And that is one of the reasons why we have to adopt automation.
A very basic level of mechanization with the sub. Very basic, but there's nothing wrong with that, right?
Exactly.
Yeah.
So maybe some of the great benefits is just when you're welding in a hot environment, for example, and you have to stand over a positioner, rolling pipe day in, day out in 40-degree weather, that's not very appealing.
That's tough.
And when you bring a robot into that equation, guys really like it. Mm-hmm. People really see the benefit. They're okay, so you're getting twice the productivity. You're not burning your body in your face. You're actually quite comfortable behind a computer monitor. But you're still watching the weld, and you're still affecting the weld.
Yeah, you're still doing your trade.
Exactly.
Yeah. You're still doing the art of your
So it's still your weld that you can have an effect on.
Yep.
It's just happening faster, safer, better, stronger.
And your interface is through the pendant, not through your hands.
Exactly.
Right?
So I don't have a big issue of communicating this with people on the shop floor when I'm, in front of them, talking to them.
Yeah.
But they do get, I guess, a negative, expression when they first hear the word robot.
Yes. It has a negative, talk about negative connotations. It has a historical negative connotation. Stealing jobs. It's going to take my job away.
Yeah.
What does pretty much every Novarc customer say? We put a robot in. We didn't fire welders. We got to hire welders.
Usually you hire other tradespeople to feed the robot.
More, and then those welders.
And you keep the welder.
Right? And those welders, those high-skilled welders, they're doing other things. They're doing in-position welds. They're doing OLEDs. They're doing other high-skilled demands of them and letting this system do the high repetitive roll welding scenarios, right? So you're freeing up your skilled labor to do more value-add tasks.
Exactly.
And I always say to the welders is this is great. You could still do traditional welding this way, but when you're in demand and your skills are needed, there's still going to be those applications where we're gonna tap you on the shoulder and say, hey, we got something over here we need you to do, right?
Exactly.
So I love it because really what you're showing is if you approach the people, the human element of it, get that buy-in, then the productivity comes, the repeatability, the quality level like we've seen, the drop in repair rates, less rework, assuming, like we talked about at the beginning, there's good shop flow, there's good fit up, there's good all those other parts. Because you could get really productive in your welding, you gotta then start assessing your other elements. So kind of full circle.
Right. Yeah, and usually it's part of a really good equation when people buy a robot like this, because that just means they're open-minded to some degree. They're investing in, tools that are going to maximize the productivity, increase efficiency.
Yeah.
And also, it's going to open the door for other technology that it's going to also enable them to save time, cut things more accurate, speed up every aspect of their, productivity.
I was in just a shop recently. The fitters had augmented reality systems.
Really?
So they were doing fit up and they could augmented reality to know the dimensions, know the fit up, see the drawings at the same time. So you think about adopting modern technology in the welding, we can adopt it to other, like we said, being the traveler, walking the life in the steel. It's actually very cool and very amazing that I hope 5 to 10 years in Canada, in North America, there still is a lot of work that we do with our hands generally, that it isn't lost to overseas, because that is a scary trend. And I think part of it is technology, like automation, augmented reality, all these very cool but effective. Like it's not cliches. They're not gimmicks. They actually serve a purpose. There is a return on investment, and I think we have to be open-minded to that, and be willing to look at what is next. Like, what are some of those cool technologies that are coming next? Like, what's some of the cool technologies that you see coming next down the line?
Well, I see a lot of laser out there.
Yeah.
I see a lot of laser, but it's not, I guess, being adopted in the field too quick because of the safety aspects, right? So there's still some safety element there that prevent it from just having it everywhere.
Yeah.
But it's pretty popular.
It is.
I see it a lot.
It's come a long way. It's actually, I've been in a couple of workshops recently. So it's acceptable to a lot of codes.
Yeah.
And these safety elements, you have to have to have a laser system, you have to have a safety officer, you have to have certain protocols in place. It's very similar to if you did RT or X-rays, you have to handle the radiant energy and same sort of protocols. But actually, one thing that's amazing, handheld lasers or lasers that would fit on the end of this system,
yep,
where all of the safety you would need is a pair of glasses.
Really?
Exist and are in use today, are being used in the field. And it's amazing because I love these sorts of technologies, because now, we have our TIG torch there, and we're talking about arcs and electrons and plasma. There, we're talking about photons. We're talking about light, but highly directional, highly controllable laser light. And it actually shows that there are these new frontiers that are not only coming, they're already here in certain niches, in certain applications. The beauty of a well thought out automation system like this, where there's a camera, there's vision, there's machine learning, there's artificial intelligence, is if we swap it out and put a laser system at the end of it, a lot of the infrastructure still works.
It's already there.
It's the bones are still good, as they say, right? And that's what I like about it, because I don't like systems or technologies that are very gimmicky.
Right.
There's no such thing as a perfect pass, right? We realize that when you do a weld and you do fit up, the fit up's not always perfect. That gap, we could give tolerances and ranges, and this notion that people say, "Oh, this technology will be perfect, this weld passes," but there's no such thing. Every weld has a flaw. Every weld ever deposited in the history of mankind has had flaws in it. You don't want.
So there is no perfect weld?
There is no such thing.
So they've lied to me.
Yes, sorry to burst the bubble, but it's been a lie. It's been a lie spread. There's no such thing as a perfect weld, but what we could do is get the workmanship to a very consistent, reliable level that what shows up is what we call flaws. And flaws we can live with. Flaws are acceptable. Flaws are expected. We don't want too many. If we get too many flaws, or if flaws get too big or the wrong shape or size through inspection, then they become defects.
Yeah.
They hit a threshold. It's like, this is now defective. And that's a really important thing for people to understand, is when you hear automation and artificial intelligence and this, then people spout lies. Say, "Oh, it's going to make perfect."
So flaws are allowed.
Correct.
A defect is not allowed.
That's correct. And that's why we have codes to define what is acceptable. Yeah. Workmanship standards of what is acceptable, what isn't. So let's use an analogy.
So I just got to switch my defects for flaws, and tell my wife that it's just flaws.
Yeah, just flaws. That's right.
It's not a defect.
I always say we're human beings. We're flawed characters. We're not perfect. But if you have defective characters, well, with your wife, you go to the dog. You sleep in the doghouse for the night, or on the couch for the night. Or if you're a really bad defective character in society, you go to jail.
You sleep in jail.
Yeah.
And when the weld is flawed, it's acceptable.
That's right. Like this weld, these passes, there's some flaws in here. I'm not to disparage you, but there's some flaws in here. But it's acceptable. It's fine.
At a microscopic level, of course, the surface is not flat.
Yeah,
it's not even.
You dig deep enough, you can find an issue anywhere. The whole intent is we have acceptance criteria to say those flaws are acceptable. We can live with it. We have the engineering design factors, the safety factors, et cetera, et cetera. Under those conditions, it's fine. So An acceptance criteria is based on the application. Whether you're building a steel building, a nuclear reactor, an offshore ship, cruise ship, a pipeline. They all have different acceptance criteria to define flaws and defects.
Based on the service.
Based on the service.
So I should have an acceptance criteria for my daughter.
Right.
Like, this is for your boyfriend. Here's the acceptance criteria.
Here's what
does not meet this, does not meet code.
He's defective. You either have to repair him, you might have to gouge him out and repair him or something.
I'll be repairing him.
Yeah, he'll be.
Right on.
All joking aside, I think it's important to have those conversations around technology. It goes back to where we started, this magic black box that solves the problem and delivers perfect paths or perfect welds, and those are gimmicks. That's snake oil salesmanship. That's not the reality. What we're talking about here is let's make it more repeatable, reliable, get the tolerances to a tighter window that your repair rates start dropping. Your flaws, if they do occur, they're few and far between. It's like, oh, there's a little porosity here, there's a little bit of this here, but we can live with that.
Right.
And you can always investigate to try to mitigate that and
remove
it, but you're not worried about a weld going out that's defective that can affect the integrity of the application.
Very cool. Well, that's very true. Yeah, I think we're always in the pursuit of excellence.
Right.
And I think that's a good mindset to keep as a philosophy, pursue excellence. But you have to sometimes settle for something that is close to perfect, but not perfect. Yeah. I think that's a really good, motivator.
Agreed. And a lot of quality culture is built around principles of quality culture, built around continuous improvement. Right? And so you understand where you're at, what your performance level is, and make an incremental improvement. Sometimes you can make relatively substantial improvements. Like root save is a feature that came in to actually help save your root pass. Like that didn't exist. I remember sitting in this shop almost 10 years ago, you and I were welding, when we talked about we should make some sort of a feature that if your root pass is going really bad, we could hit a button, right? So sometimes you make these more significant changes too. So innovation is, I guess it's not always a straight path. Is it? Sometimes it's up and down. Sometimes you almost feel like you go backwards and then maybe you start going forwards again.
Depending on what you're trying to invent. Yeah.
Right?
Yes.
So.
Absolutely, man. Well, listen, it's been a really good conversation.
Yes.
We could talk forever on all these topics, and I think we should do one on efficiency and just shop flow, productivity alone. That deserves one, right?
I think so.
And we could expand more on, attracting welders to the field. There's so much to talk about, and especially history. I love history of welding.
Yes. Well, it gives us some other after-hours topics. I like the idea of the life of the piece of steel, walking it through, and maybe we can throw some pictures up, even maybe talk about that. I think that could,
that's pretty cool because I got to work with what they used to call a traveler, and the traveler was a piece of paper that was inside a plastic binder that followed the piece from the time the metal came into the shop.
Right.
As soon as they started cutting pieces from raw stock into pieces, they had the traveler, and that traveler followed that piece until I welded it, and I had to open up the envelope, give a paper to someone to double check the critical dimensions that I did. Double check critical dimensions and sign right here. That was the traveler. Yeah. And that followed that piece till it was painted and shipped.
And it's cool because it shows the history. It's good for traceability.
Right.
And it also shows a level of accountability and pride in your work.
True.
And I think we talked about earlier about attracting people in to the workforce and what have you, and culture. And I think we have to get back to some of those principles too of just being proud of what we do, from an engineering perspective, from a trades perspective, whatever it is, and owning the great things and owning the challenges and being accountable to that too. And there's a lot of, it's their fault, or that can creep into a culture. And what you're describing is great because various people along the way are part of that traveler, contributing to it, verifying, validating, checking along the way, finding, if there is an issue, finding it earlier, because to fix it earlier is cheaper, quicker, and better than finding it
in the field.
In the field, that the cost just went up 10 to 100 times more expensive to resolve that same issue. Right?
Yep.
And I think that pride in what you do, if we can find ways to instill that will help attracting people in the workforce, getting the right shop flow, getting the right culture to integrate all of these technologies, and then being open to new technologies like lasers. I always make the joke, sharks with laser beams, whatever the case may be, which is coming down the line in the future.
Very cool.
Yeah.
All right. Well, we'll end it with that.
Great. Well,
cheers.
Cheers to solving the world's
To another
problem,
episode.
One weld
One weld at a time.
One weld at a time.
I like that.